Hello guys, welcome back. In the last video, we learned about the clipper circuits. So we started the applications of diodes. In that we completed rectifiers, clippers, and we solved the gate previous year problems on that. And in this video, I am going to discuss about the clamper circuits. So guys, from the last many years, there is no question on clamper circuits. It doesn't indicate that it is not important. Maybe this year the question will come. So be prepared. What I will do is, there are many clamper circuits. I will analyze one clamper circuit and I will tell you a shortcut to directly write the answer by just seeing the circuit. So in this way I will teach. At the end I will solve the gate previous year questions. So let's get started. So first we will see the definition. What is a clamper circuit? Guys, if there is an input waveform, assume it as Vm sin omega t. If we give this to a clamper circuit, it will insert a DC component. You will get DC plus Vm sin omega t. So this is the definition, guys. Clamper is a circuit which inserts a DC component into applied input signal. So they are also called as DC inserter circuits. So what the clamper can do is, either it can insert a positive DC component or negative DC component. So if it inserts a positive DC component, it is called as positive clipper. If it inserts a negative DC component, it is called as negative clipper. Let me show you the waveforms of this, guys. So if you observe here, this is a clamper circuit. I will explain this in 2 to 3 minutes. So we are giving an input waveform to the clamper circuit. So what is our output? See, input voltage is here, but the output voltage is shifted upwards. So we are inserting a positive DC. That's why signal is shifting upwards. So it is called as positive clamper circuit. Next, this is our input waveform. This is a clamper circuit. Our output waveform is shifting downwards. So indirectly we are inserting a negative DC component. That's why it is called as negative clamper. This is positive clamper, this is negative clamper. Now what I will do is, I will explain the working of negative clamper. And I will tell you a small shortcut. With that shortcut you can answer any question. So let's proceed. If you observe here, this is our input waveform. The output waveform is shifted downward. So it is called as negative clamper. Now we will see how it works, guys. Forget about these polarities. I will teach you. So this is our clamper circuit basically. Now we will analyze this clamper circuit. So what is the first step in the analysis? Open circuit the diode. So this is the equivalent waveform, guys. Now initially capacitor is uncharged. Capacitor is uncharged means voltage across capacitor is 0 initially. So if voltage is 0, capacitor acts as short circuit. So if you see here, guys, capacitor is acting as short circuit initially. This is the P type of our diode. This is the N type of our diode. So during the positive half cycle, positive is applied across P type and negative is applied across N type. So what is the condition of diode? Short circuit. So if you observe here, this is our equivalent circuit. Now this is the voltage across capacitor. If you observe in the circuit, voltage across capacitor is equal to input voltage. So I am calculating the current across capacitor here, I. What will be I? I is nothing but C into dVc by dt. So this is the capacitor current equation, guys. If you observe here, in this term cos omega t is coming. So this is the current through the capacitor, and current through the capacitor is same as current through the diode. The same current will flow here. But if you observe this current equation, it is cos omega t. That means this is the equivalent waveform. But diode won't allow reverse current. You know that, right? So see here. From here to here, diode is allowing the current. But whenever the current is going into the negative direction, diode will become open circuit. So if you see here in this waveform, it is the input voltage and this is the capacitor current. The amplitude is not same, but the interval is same. So this is the capacitor current. At instant t1, it is going into reverse direction. So since diode won't allow the reverse current, what it will be? Diode will get open circuited. Okay. So here to here, diode is in on position. Let me draw the equivalent circuit there. Sorry, I have already drawn it. See, from 0 to T1, if diode is in on position, what is the output voltage? It is equal to 0. So from 0 to T1, you are getting 0 output voltage. Next, after T1, diode gets open circuited. And another important point is, since capacitor voltage is equal to Vi, at T1, Vi is equal to Vm. So capacitor voltage will be also equal to Vm. And after T1, diode will get open circuited. There is no path for discharge for the capacitor. For capacitor to discharge, there is no path. So capacitor will retain its voltage. Its voltage will remain at Vm only. Why? Because it is charged to the Vm. After Vm, diode is getting open circuited. If diode is open circuited, there is no path for the discharge of capacitor. So it will remain at the voltage Vm only. Got it, guys? So this is the equivalent circuit after T1. So I am representing capacitance as an equivalent DC source. Why? Because it is charged to the Vm and it will retain its voltage. So I am writing this as Vm. Now what will be output voltage, guys? It will be Vi minus Vm. Indirectly, Vi is shifted by Vm downwards. If you observe this waveform, it is Vi. Vm is 10. So Vi minus Vm. This positive is shifted to 0. It is shifting to 0. Similarly, if you observe this, this is 0. It should be shifted to Vm. So it is shifted to 10 here. And it is already at minus 10. It should be shifted by minus Vm. So it will again shift by 10. See, you are getting minus 20. Indirectly, this waveform is shifted downward by 10. Why 10, guys? Because Vm is equal to 10. If Vm equal to 5, this waveform is shifted by 5. So up to T1, it is in short circuit. So output voltage is 0. After T1, output voltage is shifted downwards by Vm. So this is the output voltage, guys. So up to here, it is a transient waveform, not steady state waveform. From here it is steady state waveform. So this is the explanation of clamper circuit, guys. Now I will tell you a shortcut. With that shortcut you can write any waveform directly. So shortcut is, first see the diode direction, guys. If diode is downwards, then the waveform is shifted downwards. If diode is looking upwards, then the waveform is shifted upwards. It is the first point. So I wrote the same thing here, guys. If diode is looking downward, then the signal is shifted downward. Draw output waveform below the reference voltage. Reference voltage is nothing but the voltage which is there here. In some circuits, he will give like this, some +2, -1 and some. But here in this circuit, the reference voltage is 0. If it is downwards, then draw output waveform below the reference voltage. Since reference voltage is 0, it is the 0. Draw this output waveform below the reference voltage like this. Similarly, if the diode is looking upward, then the signal is shifted upwards. Draw output waveform above the reference voltage. But friends, before drawing this, I will tell you the 3 properties of clamper circuits which are very important. So first property is no change in the shape of the signal. This means if you apply input voltage sinusoidal, you will get output voltage as sinusoidal. If you apply input as square, you will get output as square. So this is the no change in the shape of the signal. But if you apply sinusoidal, you won't get square output. You will get sinusoidal only. So it won't change the shape of the signal. Next, no phase difference between the input and output. So what will clamper circuit do is it only shifts the signal. It won't change the properties of the signal. Next, V naught peak to peak equal to V in peak to peak. See this peak to peak voltage from here to here will remain same. So from this what you can conclude guys, this clamper circuit only shifts the signal upward or downward. It won't change the properties of the signal. Above shifting it won't do anything. So if it shifts upward it is called as positive clamper. If it shifts downwards it is called as negative clamper. Above that it won't do anything to the signal. So I'm writing a note point guys, it is except shifting it won't do anything to the signal. It won't change the shape, it won't change the phase difference, it won't change the amplitude, peak to peak amplitude. It will only shift the DC signal. So it is the shortcut. These are the properties guys. Using these two we should write the output waveform if the input waveform is given. So guys, there are not many questions asked from the clamper circuits in the previous examination. So what I am doing is I am taking directly examples. I will solve some 5 to 6 examples and you will get some idea about this. So see, it is the input voltage and this is our clamper circuit. What is the first step? Check the direction of the diode. So diode is pointing downwards. So what does this indicate? This waveform is shifted downwards. Next check the reference voltage. Reference voltage is 0. So since reference voltage is 0, draw the waveform below the reference voltage. Why? Because it is shifted downwards. Downwards below the reference voltage. So it is the input waveform. See, we are drawing below the reference waveform. Reference voltage. There is no change in shape. There is no change in peak to peak amplitude. And there is no phase difference. The same waveform is appearing again. So in this manner you should draw the output waveform. So moving into the next example. If you see here, in this circuit, diode is pointing upwards and the reference voltage is 0. So what we should do? We should draw the input waveform above the reference voltage. Why above? Why not below? Because diode is pointing upwards. So we should shift the waveform upwards. Upwards above the reference voltage. So since the reference voltage is 0, we are drawing the waveform here. The shape, phase difference and peak to peak voltage will remain same. So this is the procedure to draw the output waveform. Moving into next example. So if you see this example, what is the first step? See the direction of diode. It is pointing upwards. So we should draw the same waveform above the reference voltage VR. Observe the output waveform. This is the reference voltage VR. So we are drawing the same waveform above the reference voltage. But there is a small mistake here guys. Check what it is. See, if you observe this waveform clearly, peak to peak voltage is changing. Here the magnitude is 2Vm. Here the magnitude is VR. So peak to peak voltage is 2Vm minus VR. It is changing. It is not same. So this waveform is wrong. So this magnitude will be Vm plus VR. This magnitude will be 2Vm plus VR. We should draw the waveform like that, such that the phase difference, the shape and the peak to peak magnitude will remain same. See, if the least voltage is minus Vm, we should add Vm to make it 0. If the least voltage is VR, we should add Vm to make it reference voltage here. So VR plus Vm is this point and VR plus 2Vm is this point, such that our peak to peak voltage will remain same. If you observe this circuit, here the diode is pointing upwards but the reference voltage is negative. So we should draw the waveform above this negative reference voltage. See, this is minus VR. So we are drawing the above of this reference voltage minus VR. So this voltage will be 2Vm minus VR. This voltage will be Vm minus VR. Understood guys? Moving on to the next example. If you observe this waveform, the diode is pointing downwards. So what we should do, we should draw the waveform below the reference voltage. So this is the reference voltage positive VR plus VR. So we should draw the waveform below the reference voltage. So what will be this voltage? Minus Vm plus VR. What will be this voltage? Minus 2Vm plus VR. Next, see this waveform. Diode is pointing downwards and the reference voltage is negative. So what we should do? We should draw the input waveform below this reference voltage. See, this reference voltage is minus VR. So what will be this value? Minus Vm minus VR. What will be this value? Minus 2Vm minus VR. Such that our peak to peak voltage and the shape and the phase difference should remain same. So these are some of the examples of clamper circuit, guys. Next, there is an important concept called as voltage doubling circuit. So guys, this is called as the voltage doubler circuit. What this circuit will do is, if the peak voltage of input waveform is Vm, then we will get output as 2Vm across the capacitor. So let us see how it will work. So what is the first step? Open circuit the diodes. So if you see here in the positive cycle, P is connected to positive, N is connected to negative. So this diode will be in on position and this diode will be in off position. See, since this diode is in on position, the input voltage is equal to capacitor voltage. So we already derived the current equation. After time t by 2, this current is going into negative direction. So what will happen? This diode will become open circuit after time t by 2. What is t by 2? Not t by 2 guys, after t by 4. So here to here capacitor charges. At Vm, this diode will become open circuit. Why open circuit? Because current is flowing in the reverse direction. I already explained this concept. So this diode will become open circuit. If this diode will become open circuit, what is the capacitor voltage? There is no path to discharge. So capacitor voltage will remain at Vm. But what about the input voltage? Input voltage is decreasing. So V input minus Vm. Capacitor voltage remains at Vm. Why? There is no path for discharge. But V input will decrease. If you observe this waveform, it is the capacitor voltage, but V input is decreasing. So what is V input minus Vm? It will be negative. So if you see here, negative is applied to N type. So now this diode will become forward biased. This is reverse biased. This diode will become forward biased. So now this is the equivalent circuit, guys. So what will happen is, it is the input voltage Vi. Now let us take like this. See, this is our capacitor voltage. Since this is the direction of current flow, this is our capacitor voltage. So I am writing this as Vc. Apply KVL here. What you will get? Minus Vm plus Vi plus Vc equal to 0. So what will be Vc voltage? Vc equal to minus Vi plus Vm. This is the capacitor voltage. So what will happen is, when Vi reaches the 3t by 4, that is minus Vm. When Vi reaches minus Vm, the capacitor voltage will charges to 2Vm. The Vc will charge to 2Vm. After this, the same thing will happen. Since the current direction is this one, if you find the current across the capacitor, it tries to enter in the negative direction. So this diode will also be in off position after 3t by 4. So now what is the output voltage? It will return at 2Vm. This is Vm, this is 2Vm. So this is the voltage doubler circuit, guys. So this is the previous year gate question. He given a circuit and he is asking the voltage V0 across these two terminals. So if you observe here, see the direction. It is like this and it is like this and it is like this. See, if the direction of the circuit is like this, then it is voltage doubler circuit for sure. So it is having the same direction. So it is called as voltage doubler circuit. Now how to check the voltage polarities across capacitor? See the current direction. It is going like this. So it is charged to Vm in this direction. Next, check the direction here. It is going like this. Only first capacitor is charged to Vm. Remaining all capacitors are charged to 2 Vm. So it is going in this direction. So it is charged to 2 Vm. Plus minus. Wherever the current is entering, it is plus terminal. Remaining is minus terminal. Next. It is going like this and it is entering in this manner. So this is plus, this is minus. This is also charged to 2 Vm. Only first capacitor is charged to Vm, remaining all are charged to 2 Vm. So now what is the output voltage? Vm plus 2 Vm. That is 3 Vm. Got it, guys? First draw the direction. After drawing the direction, check the polarities. After checking the polarities, calculate the output voltage. That's it. So this is also previous year question, guys. See, if you observe here, this is the direction of current. So this is also a voltage doubler circuit. Next, what is the next step? Draw the polarities of the voltage. Since it is 6, it will charge to 6 in this direction, and the direction is like this. So it will charge to 12 in this direction. So what will be Vc1? Vc1 will be 6 and Vc2. Vc2 he given the negative polarity, means reverse polarity, but original polarity is this one. So what you should write? Vc2 is minus 12. That's it. So next question. So this is not voltage doubler circuit, guys. This is a clamper circuit. He gave the input voltage and he is asking us to find the output voltage. So what is the first step? See the diode direction. It is pointing downwards. So draw the same waveform below the reference voltage. So below 7 volt, draw the same waveform. So let this be 7 volt. Below this we should draw this waveform. So what will be this point? Since it is 7, it will be minus 3. Since it is minus 3, the end point will be minus 13. So this is the 7 volt, guys. Our peak to peak should remain same. What is the peak to peak here? 20 volt. So for peak to peak should be 20 volt. What is this voltage? 7 minus some x equal to 20. So what will be x? Minus 13. This voltage should be minus 13. So what will be the reference voltage? In between 7 and minus 13, that is minus 3 volt. Or just add minus 10 to the 7 volt, you will get minus 3 volt, and again add minus 10 to minus 3, you will get minus 13. So this is the output waveform. See the diode direction and see the reference voltage. Draw the same waveform below the reference voltage such that your shape should not change, your phase should not change, and your peak to peak value should not change. So in this question, if you observe, guys, input voltage is 3 plus 5 sin omega t. Not only 5 sin omega t, you are also having 3. So what is the concept here is, if you see the impedance of the capacitor, it will be 1 by omega c. For DC value, since frequency equal to 0, this will be 0. So impedance will be infinity. Since indirectly it is open circuit. So whenever you apply DC value, capacitor acts as open circuit. So it won't allow DC. Capacitor blocks the DC component. So indirectly what is here is, you can remove 3 because capacitor won't allow 3. We are only applying 5 sin omega t. So this is the concept, guys. Don't mix output voltage by considering this input DC voltage. Capacitor won't allow this DC voltage. The signal which is clamping is only 5 sin omega t. Why? For DC, capacitor acts as open circuit. So now what is the input, guys? 5 sin omega t. What will be the output? Check the diode direction. It is shifting downwards. Reference voltage is 0. So draw the waveform below reference voltage. Like this. Since it is 0, it will be 5. It will be 10. See the peak to peak voltage. Peak to peak voltage is remaining constant, that is 10. So that's it. So this is the end of the topic clamper, guys. If you like my explanation, do like, share and subscribe to my channel. It really motivates me to do more videos. So we will meet in the next lecture. Thank you.